All right, algebra, we are in chapter 3, section 4. Solve equations with variables on both sides. So here we have an equation, and we have the w's on both sides of the equation. So you might pause the video and give it a try. All right, so there's more than one way to solve for w, but here is a strategy that can be really useful. We want to move the variables first, collect them to one of these two sides. So what side would be easier to collect these variables to? Actually, it would be to the side with the greater value of the coefficient. So which side has more w's? Negative 2w's or positive 6w's? This side, right? So we're going to move the negative 2w's over, or we're going to add w to both sides, right? When we do, then this term with the w's is positive, right? If we subtracted 6w from both sides, we would have negatives, which are tougher to work with. So on the left side, we end up with 8 alone, right? 8 equals, what, 8w plus 8. I'm sorry, minus 8. Okay, welcome back, algebra students. Today we're going to solve equations with variables on both sides. So each day we're getting a little more sophisticated. As we look at this equation, we see that we have w's on both sides. So you might recall a strategy we use to try to keep our variables positive, trying to avoid too many negatives where we can, right? So how can we move these w's so that they're positive? Well, which side has a greater number of w's? Good, the right side. It has 6 w's. The left side has negative 2 w's. So we can move the w's from the left side to the right side by adding them, right? That leaves us with 8 equaling 8w minus 8. Interesting, all these 8's, right? So now we're going to try to leave the w on the right side, right? So what will we do? How about adding 8 to both sides? Good. All right, and when we do, look at that, we actually have 8 plus 8, or 16, equals 8w. And I'm sure you know the property we'll use now. Division, property of equality. Divide both sides by 8. And we end with 2 equals w. Now let's just do at least a little mental check to see if this is the correct solution. We'll plug 2's in up here. So 8 minus, what is 2 times 2? 4. Good. So 8 minus 4 is 4, right? The left side would equal 4. And 6 times 2 is 12. 12 minus 8 is 4. So 4 equals 4. Very good. So we simplify each side of an equation, right? And when we have the same variable on both sides, we collect the variables to one side, usually to the side with the greater coefficient of the variable. Let's go ahead and try again with this second problem here. Once again, we have x's on both sides of this equation. So which side has a greater coefficient, a greater number of x's? And this time we see 5x is greater than 2x, right? So we'll move the 2x's to the left side by subtracting 2x from both sides. And we end up with 13 plus 3x equals, be careful here, what is left on the right side? Negative 8. Good. Okay, so now we simply solve for x. What shall we move first? 13. Subtracting 13, we have 3x. Now when we're subtracting, you could look at this as adding the opposite, right? We basically have two negatives here. So 13 and 8 give us negative 21. Okay? Now we simply divide by 3. So x equals, don't lose your negative, negative 7. Okay? Let's go ahead and check the work by rewriting and plugging it in. So we have our negative 7. We'll plug in for x. There There it is. And the question is this true? That 2 times negative 7 minus 8 equals the left side. Okay, so 5 times negative 7 is negative 35. And over here we have negative 14 minus 8. All these negatives, right? So 13 plus a negative 35 would be negative 22. And does that equal negative 14 plus a negative 8? Yes, it does. Negative 22. If you are in a test situation, you can take your solution through the original equation to confirm that you're correct. All right, how might we solve this equation that has grouping symbols? Well, we learned yesterday that sometimes, especially when we have a fraction out here, we could multiply both sides of this equation by the reciprocal, right? But as I look at this equation here, I see that this fraction 1/5 would multiply really nicely with the two terms in here. So we might instead use a distributive property this time, right? So we definitely need to simplify and lose the grouping symbols, right? We can do that in this problem by multiplying 1/5 times 5x. Look at that, the 5's will cancel, giving us 1x plus 1/5 times 20, right? And 5 goes into 20 4 times. Good. So once we've simplified, we no longer have the grouping symbol, and we can look to collect the variables to the side with a greater number of variables. This x, again, how many x's are here? 1. We might put that coefficient in. So there are more x's on the left side, so let's subtract 1x from both sides, leaving us with 3x minus 5 equals 4. And go ahead and finish. I'm sure you're adding 5 to both sides. We have 3x equals 9. And division property of equality, x equals 3. Good. So once again, we could substitute this into the equation. Let's just do it mentally this time. 3 times 4 is 12. 12 minus 5 is 7. So this side is 7. Let's stick a 3 in here. We have 3 times 5 is 15, plus 20 is 35. And 35 times 1/5 is 7 as well. Go ahead and pause the video, try this, and check your work. I'll try this first. Okay, I'm sure you're doing this correctly. In this first one, we have which side has a greater number of k's? Negative 3k or negative 2k? Negative 2k is greater. So we could move the 3k's to the right. When we do, look at what we get. 17 plus 1k. So positive k. Now if you moved your 2k's to the left, you can still find the correct solution. This strategy of moving your variables to the side with a greater number leaves us with more positives, which is why I like this strategy. So we can subtract 17k is beautifully positive, right? And what is 9 minus 17? I believe it's negative 8. Okay, very good. And let's try this next one here. So we learned with the grouping symbol that we can go ahead and distribute, right? 5a minus 15, right? Equals 3 minus 4a. We could change this to adding the opposite, and we see that the right side has a greater number of a's. So what is the inverse of negative 4a? Positive 4a. We're going to add 4a to both sides. And we end up with 3 equals 9a plus negative 15, or minus 15. The inverse of positive 15, I'm sorry, negative 15 is positive 15, so we're adding 15 to both sides. And we have 9a equals 18. I'm sure you use division to finish, right? And we have a equals 2. Good. Let's try one more and then we'll do something new. Pause and come back. All right, so when we distribute, the 3 can divide nicely into these numbers, right? 3 goes into 6 2 times. 2 times 2 is 4. 4 y's. 3 goes into 15 5 times. 5 times 2 is 10. Okay, over here we have 8y minus 6. So which side did you move your y's to? I'm hoping you moved them to the left side because 8y's are greater than 4y's. And we have 4y minus 6 equals 10. You simply add your 6 and 4y equals 16. Using division property of equality, y equals 4. Good job. All right. There's something called an identity. You know that identity property of multiplication, we multiply any number by 1 and it stays the same, right? So identity has something to do with keeping a value or an expression the same. So an identity in this case is an equation that is true for any value, any number of the variable. So in other words, x equals x. How many solutions would this have? I guess it's infinite, isn't it? Because I could plug any real number in here and it would be true that x equals x. All right, so how does this appear in our equations? So is this an identity? Well, to determine whether we have the same expression on both sides of the equal sign, we could distribute, right? So we end up with 5x minus 5 equals 5x minus 6. Is that an identity? Well, if we try to solve this, we could, first of all, try to collect the variables to one side, and we do that by subtracting 5x from both sides, since they're the same, and we are left with a really strange equation. Negative 6 equals negative 5. Is this true? That's a question mark. Is this true? Does negative 6 equal negative 5? No. So this whole equation is a false statement. So if we're asked how many solutions does this equation have, we would say 0 solutions or no solutions, because it actually is a false equation. It doesn't make any sense. All right, let's look at the next one. Okay, once again, it looks a little complicated, so we're going to simplify and see what we have by distributing. 4 times 3x is 12x, plus 4 times 2 is 8, equals 12x plus 3 times 4 is 8. Interesting. We have the same expression on both sides of the equal sign. So how many solutions will this have? Infinite. You know, we can see that if we actually try to collect our variables to one side. In this case, we would subtract 12x from both sides, right? Trying to gather them all in one place. And look at what happens. We end up with 8 equals 8. The variables are entirely gone. And at this point, we could actually subtract 8 from both sides, and we would have 0 equals 0. So in all of those cases, the statement is true. So we would say we have infinite solutions. You could also use a symbol for infinite, like a sideways 8. Okay, so when we solve an equation, we might find that there is one solution. In many cases, we're solving those types of equations, right? One solution for this equation. We might find that the statement itself was false. When we simplified it, we got this really strange false statement that negative 6 equals negative 5, so there's no solution to those types of equations. And finally, we might end up with equations that lead us to x equals x, so 8 equals 8, or x equals x, a true statement, and in that case, we have infinite solutions. All right, so you may begin your assignment, and be sure you check it so carefully. Don't forget there is a quiz at our next meeting. Okay, have a good weekend.